Now let's move on to a function called reduce. Reduce is a bit more complex than map or filter, but what's interesting is that map and filter can actually be implemented in terms of reduce. But before we get to that, I want to show you some examples of what reduce does. So reduce is something that you use to iterate over a collection and successively generate results and build on those results as you go. For example, let's say you have a collection of numbers, and what you want to do is compute the sum of these numbers. And you can use reduce to do that. Of course, as always, there's a built-in reduce function to do this kind of thing, but again, we want to build it from scratch. So if you already have, or if you have a function that can add numbers, let's say we build that now. Then you could pass this to reduce to add all of these. Now, how does that work? Because plus only takes 2 numbers. And here we have 3 number, maybe more. So the way this works is it first reduce passes in 1 and 2, calculates the result, which is 3, and then it iterates a second time, passes the result as the first one, and this 3 as the second one. So then it does 3 plus 3. So let's see this in action. There you go. So that's what reduce does. Reduce can also be used for other things. So for example, you could use it to add this, but also provide a starting point. Let's say 10. So you can pass this additional parameter as a starting point, and then it adds all of these to this starting point. But you could use it for wildly different applications too. So for example, I'm going to pass the inline function now because I haven't declared these. Let's say you want to rotate an array. You want to reverse the order of an array. So for example, you want to turn 1, 2, 3 into 3, 2, 1. One way to do that is using reduce. And you can use reduce in this way. So you're going to pass a function. And as I said, I'm declaring it inline now because I haven't declared it yet. And it's common to name these 2 arguments that reduce passes to the function that you give it. Acc for accumulated result and curve for the current element that you're iterating with. And then what we can do is we can create a new array with the current element and then the accumulated results that we have generated so far. And we pass in our array that we want to rotate. And in this case, we have to provide a starting point, which is an empty array. So whenever we don't provide a starting point, reduce automatically takes the first item in the array as the starting point and iterates only over the remaining items. But in this case, we want our result to be an array, not a number. So we have to provide an array as a starting point. And then it takes this whole collection and iterates over all 3 items. And there you go. This is how you rotate an array using reduce. And the name reduce is maybe a little bit misleading at times because the resulting collection, if it is a collection, doesn't have to be shorter or smaller than the collection that you pass in. For example, you can equally well use reduce to duplicate every item in a collection. The way you would do that is like this. Oops, forgot to actually duplicate it. There you go. So what happens in this case is it takes an empty array as a starting point. Then it takes the empty array in the first iteration as the accumulation, the accumulated result. And cur is 1. So what happens here? It takes nothing, it flattens, so to speak, the empty array that we're given, and then puts 1, 1. That's how we get this. Then it iterates again. This time ac is an array with the elements 1, 1. Cur is the element 2. So we have 1, 1, 2, 2. And then it does this again, and ac is now 1, 1, 2, 2. And then it adds 3, 3. And then it stops because it's iterated over the entire collection. So that's what reduce does. Reduce is a very powerful function. You can use it in all kinds of contexts. So again, we could implement reduce in the standard sort of convenient looking way, but that's actually harder to reason about. And let's give it a try. So what we're given is a function f, a collection, and some initial value. And I believe calling it val, that's actually exactly how they do it in Clojure, if I remember correctly. And now what we want to do is, now let's pretend we don't have any of the functional helper methods that we wrote before. So we have to check, as always, if our collection is empty. And if it is, now it's kind of up to you what you want to do here. You could say if an initial value is provided, just return that value. That value might be undefined. So if it is undefined, you may choose to throw an exception here or something. I think that's what JavaScript does by default, but that's a detail. Let's just return it even if it is undefined. Now, if there is something in the collection, and we really do have something to work with here, then the standard sort of approach would probably look something like this. We would prepare, as always, some result variable. Then what we have to do, as I described here, is if we don't provide an initial value, we have to pick the first one as the initial value and then iterate over the rest. So we have to check, is the value not given? And if that is the case, we simply say, well, all right, then our result, we simply manually set it to the first item in the collection. And we reassign the collection to just be the rest of the collection. We could just use rest here, but remember that in this case, we're pretending that we're not doing anything functional. So we're not going to use any of the helper methods that we declared above. If we are given an initial value, then we don't touch the collection. We leave it as is, and we simply set the result to be that initial value, because that's what we're starting with. Okay, and then what we do is we iterate again over the entire collection, and we say the result is simply whatever the function returns for the previous result and the current item. And then at the very end, we return the result. So let's go over it again. We're given some function, we're given a collection, and we're given an initial value, optionally. If there is nothing to iterate over, then we simply return the initial value, even if it's not given and it's just undefined. If there is something to iterate over, we prepare some result variable that we're about to reassign constantly. And if no initial value is given, then we say pick the first item in the collection as the initial value and only iterate over, like reassign the collection, reassign the rest of the collection to the collection variable. But if the initial value is defined, then we start with a result preset to that initial value. Okay, and then we iterate over every item in the collection. And this is really the core, this is really the crux of what reduce is supposed to do. Iterate, and at every point, reuse the result from the previous iteration. And then at the very end, once we're done iterating, we return the result. So let's see if this still works. So let's say reduce plus over 1, 2, 3. And there you go. So this looks fine. And let's also make sure that it works with an initial value. And it looks like it does. But again, this is the traditional approach, and we can do better. We can write this in a functional way. So let's write this again. And as always, the signature is the same. But things are going to look a bit different now. Basically, what we're going to do is check, as always, is our collection empty? And if so, we simply return the initial value that we're given. And again, it's sort of your call. If the value is undefined, you may choose to throw an exception here. If there is something to iterate over, pick the first item from the collection. And now we have to check if the initial value is undefined, because remember, if the initial value is undefined, we have to use this as the initial value, this first item from the collection, and iterate over the rest. So we're going to do the same check if the value is undefined. We want to basically skip over this iteration. So rather than reassigning some variable or multiple variables as we did up here, we're simply going to say, you know what, don't even bother continuing, simply return and reduce again with the same function, this time the rest of the collection, and this item set as the initial value. But if the initial value is defined, we don't have to do this. We don't have to use the first item as the initial value, and we can iterate over all the items in the collection. In that case, what we want to do is compute the result, and then we want to return the result, or we want to return whatever reduce returns for the rest of the collection. And there we go. So let's make sure that this works. And it looks like it does. So let's try to run this for some of the examples I ran before, just to make sure that it still works for everything we want it to work for. If we run it for plus 1, 2, 3, this works great. If we run it for an additional value as well, or an initial value, I should say, it works fine as well. What if we run it to reverse an array? This works also. And then the final result, the final example that we had was that of duplicating some items in an array. And this works as well. So there you go. This is how reduce looks in a functional implementation. And I really like this implementation a lot better because there's a lot less going on here. We don't reassign any variables, and we're not mutating anything either. And although, to be fair, I don't think we mutated anything here either. But this function is a lot shorter, and it's much easier to reason about. And I think it's a better program overall as a result. Now, what may be confusing initially, and I remember struggling with this at first when I first started learning about reduce, is this ACK and cur thing. And it's helpful to just remember that ACK is just whatever the last iteration returned. And that is how you successively build up results. And this is really what makes reduce so powerful, because you can use it for all kinds of successive, for any use case where you want to successively and iteratively build on intermediate results, you can use reduce. And that's a lot of use cases. A lot of problems you can reduce literally to a problem where you can use the function called reduce. So it's a very powerful and helpful function. So that's reduce for you.